We're here at SCWS World and I'm talking with Juniper Networks' Ian Getz. So Ian, we're hearing a lot at this event about the evolution of 5G and NFV. Can you tell us a little bit about how Juniper sort of positions itself in regards to that?
Okay, well obviously Juniper's very strong in IP routing and security. With 5G coming through, there's increased emphasis on security. There's also, if you look at the way 5G and LTE advanced before it evolve, there's a need for much more coordination in the radio layer between base stations. That means that whereas in the past mobile radio guys would have come to the IP team and said, give me a pipe from A to B, certain size and a reasonable frequency timing standard on it, now they need much more coordination. They need low latency coordination, and they also need, because of the IPsec capabilities used to protect the traffic between a base station and the core, they now need distributed security. They also need phased timing. Now these are all things that Juniper can provide in its IP platforms. Of course, the other part of 5G is the NFV network slicing side of things. Juniper is a leader in NFV and SDN control. We have partnerships for how we've integrated our SDN controllers with people like Affirmed, their EPC, so we can show network slicing and early capabilities with the CUPS model, working on an OpenStack NFV environment. And with our mobile cloud architecture, we can show how that technology can then be spread throughout the network, and hence mobile edge computing.
Mobile edge computing, that's the big buzz phrase at the moment. Can you explain a little bit about how that works and what the business case is for it?
So mobile edge is about providing application environment at the edge of the mobile network. It evolved out of actually an internal Vodafone project from a few years ago called Savvy. They decided that they needed that to go into the standards in the arena, and hence they, along with other companies, founded Etsy ISG MEC. Juniper's been active in there since pretty much a couple of months after the standard was activated. What it does is it gives you the ability to run applications that require low latency. If not low latency, would benefit from the distribution because of the amount of bandwidth, that sort of thing. And it gives you access to real-time radio information to help tune application delivery as well. So Juniper's taken its SDN NFV capabilities. We see a lot of synergy between the issue of running MEC at the edge of the network in terms of thousands of compute nodes and the whole enterprise SD-WAN environment where we're looking at running thousands of compute nodes at the end of that network. So we see synergies with our cloud CPE offerings as well. In terms of the business case, if you just look at the deployment costs between the base station and the hub site, we think the hub site's the best place to put it because you can concentrate compute. You only lose a couple of milliseconds in delay, but you can now roll out the whole network much quicker, much more cost effectively, and I think the business case we've shown does something in the region of 6 times the return on investment for using the hub site compared to using the base station. The problem with that means that you're now working in an IPsec environment. So obviously Juniper's expertise in the IPsec space for LTE security gateways is a great advantage there.
And the Internet of Things, IoT, a lot of people are talking about it at this event, and certainly the big ticket items for IoT, smart cities and automotive applications. How does MEC help with that?
Well, in terms of IoT generally, a lot of IoT devices are battery powered. They rely, many of the industry verticals rely on quite a long battery life. They're looking at years. Sometimes people take a while to grasp this one, but if you host the application that is IoT devices relying on, either in the mobile core, where it's probably in the region of 50 milliseconds away from the base station, 50 milliseconds away from the device, or in the cloud, it can be hundreds of milliseconds away from the device. So that means the radio transmission time that device is on, transmitting data, waiting for an acknowledgement, waiting for the next level of information from the application, is quite long. If you can host it at the MEC server down on the hub site, your latency is now 12 milliseconds. Now, scale that up over the life of the device, and the device battery life goes up by in the region of 50 to 75%, depending on where in that curve of long latency the original application was. And that in itself is a substantial business case for the verticals that the mobile operator is trying to deal with. The other area in terms of smart cities hits another value proposition, and that is the low latency. Certain applications you need very low latency. The brake light example of, you stand on your brake light and my car reacts before I do. You can't do that through the network. But you can augment those systems and augmented autonomous vehicles through the network. That means running the MEC server on the hub site gives you the latency that you need for those classes of augmented autonomous vehicles. Then you get to the next level of problem with the IoT and automotive space, which is security. We've already seen just before Christmas some pretty large Mirai attacks from infected IoT devices. If you think about a mobile network, there is nothing between the base station and the egress point from the mobile network to prevent those attacks. We think we're running secure because we have a SIM that authenticates to the network. We have IPsec protecting the traffic from the base station to the core. But if the device itself is infected, all we do is wrap that infection and that malware in IPsec, deliver it to the core and the internet to do as much damage as possible. So we have a proposition where, with MEC, by opening GTP, we can inspect traffic. And it does. I don't necessarily mean inspect everybody's traffic, but we inspect the traffic for the companies that want us to keep their network clean. And we can detect the attacks. We can run it through our SDSN product offering. That analyzes policy centrally and then pushes that policy out to multiple points in the network. So it's like a defense in depth. But also, if you get an attack on one MEC server, say in London, within seconds or minutes, you can have the whole country protected against that new attack. So those three key areas seem to be a very strong direction for Juniper and for the markets that we're addressing in mobile edge computing.
Ian, it's a really exciting time for you guys. Thank you very much.
Thank you very much for your time.